So continuing with time values, we're going to look at time expressed in seconds. Now I'll come back here and I'll comment out this line and uncomment this line. And let's try evaluating this. This should do more or less the same thing, except instead of doing it in 1,000 frames, it should do it in 100 seconds. And click the Create Curlicue Fractal. So here it says no exponent function for 0.625f. So I'll click OK there. So we're getting a number with an f on the end of it, and it doesn't want to give us an exponent for that. As we're asking for here, we're asking for that h squared. So let me bring up the listener, and here I have a little test file that we can look at this with. So here we have for 0 to 10 do, and here we have for 0 seconds to 1 second by 0.1. And we're going to print t and we're going to print h and evaluate all. So here you can see we get numbers with no f. And on the second round, you can see we get numbers with the f. So that's what's creating our problem. And if you ever run into this, the way to solve it is by coercing the time to use the frame's integer. It's not really an integer, it does have a decimal component, but it reduces it to a number with no f on it, using the dot frame property. Right here. So you can take any time unit and make it appear as frames with this dot frame property. You could also do the same if you want it to appear as ticks. So let's try this again. Let's print t frame, and I'll use t frame here as well. I'll just Control D to erase all that and evaluate. So you can see in the second one, we went from 0 seconds to 1 second. Since we're at 30 frames per second, we got 30 for t at the end. And the numbers, most importantly, don't have the f. So we're going to try that same thing in our other script here. Right here where we have the t, we'll put t frame. And then we'll see if we have that problem with h down here. And this is the shape it created. And because we've got 100 seconds and 30 frames per second, we've actually got around 3,000 frames here. So if we want to see the whole shape that was created, and I'll just zoom extents here. So it looks like this created a perfect circle in this case. Notice that the amount of the movement, which is determined here by J is determined by H is determined by T. So because the times change here, T changes, the amount of the movement changes, and the shape changes. And I'll save this as time 02, and that'll be available in the work files.